Hello, everyone. I'm really happy to be here. It's a pleasure. Thanks for the organize for this nice event. I'm going to talk today about some discussions that we had within the AI for Soil Health. When we wrote the AI for Soil Health application, there was no soil monitoring law. So we are adapting to fit to the new conditions. Also because the main aim of AI for Soil Health is to support the soil mission. I think everybody knows this now. About 60% of the soils in Europe, they are under some kind of degradation. And if we think about 2050 to have health soils, it's a great challenge, because what we have now, for example, this information is very nice for policymakers. But if you want health soils in 2050, we need to look for the farmers, where changes must be done to get these health soils. So the challenge that we have now, the challenge that we have in AI for soil health now is to improve soil health information, not only for policymakers, but also for farmers, for local soil management. And here is just a figure from the soil monitoring law. As I said, is a great challenge. And if we think about the timeline here, in 2031, we should have the first results of the monitoring, plus the measures for unhealthy soils. And then in 2032, we should start restoring soil. But do you have this information? What Ton was talking about, what is health, what is unhealth, the thresholds, how to define it, the different scales. So there are many open questions still. And this, we are trying to find some answers in AI for soil health. Here we have, just to show to you the different scales. So we have a EU scale, we have national scale, and we have local scale. So can we provide information for both scales? Not both, but for the, let's say, the three scales. The two first could inform policy making, but can we inform farmers that they will be able to change the management to improve their soil conditions? The main objectives, or the main objective of AI for soil health is to create this digital infrastructure. Don already present the 14 terabytes of data to monitor soil health metrics. And here I just want to present some ideas how we are looking to it in AI for soil health in a general way. There are many deliverables here. Our friends are working in these different points. But if you think about a soil monitoring system in space and time, let's start at the beginning with the sampling down here. So we have samples. Then we can use these samples to create high-resolution maps. So samples and the high-resolution maps, they will be used by you or the member states. And then the member states, they will create, or EU, they will create decision support tools. And these decision support tools, they can be used by farmers. For example, soil health index, soil degradation vulnerability index. Our colleagues from Germany are working on it. Optimal soil management. Imagine if you are a farmer and you are on your field, and if you get information, okay, my soil doesn't look good, But if I have an option to say, if I change my management, what is going to happen in 15 years? So it's talking about scenarios. So can we develop an app where the farmer can add his information and say, okay, now I have cropping, I have just monoculture. I want to be a regenerative farming. So what will be in 15 years with my soil health? So our friends from IASA are working with some scenarios. So we are thinking about the soil monitoring system as a continuous in space and time that will be updated once we have a new samples. And but there are some challenges. And the first one, it's about the structure of the soil monitoring. To monitor something in time, we need a baseline or a stable, or I would say a stable condition. So this is now already on the revision of the soil monitoring law. It's about the soil units. We call soil monitoring units. And here for Europe, AI for soil health, we are combining two things: the climate and the soil types. Soil types are the new soil types developed in Open Geo Hub. So the idea is that we can compare. For example, if I have soil organic carbon in the North tier, I cannot compare it with the Mediterranean region because we have different climate. So once we have the soil monitoring units, we can easily compare or establish different thresholds. This paper was published by David Robson and a large group, where they explain some of this, explain the experience in UK with soil monitoring and the importance to have stable strata. Here, just an example. Let's say in 2025, we have this soil monitoring region. Is in the Atlantic North, the climate, and we have Gomes soils, right? And if you think about monitoring system, we should have the same strata until 2050. Then we will be able to say, okay, in this area, in 2050, if you look back in 2025, we had this situation, but in 2050, now we have this situation. And this is, I think, is one of the main points of the soil monitoring system, because if we create soil units with land use, we cannot go back in time and say, okay, how it was my unit before, the soil conditions in my unit before, because land uses, they are going to change. In the paper from Robson, they show that about 50% of the areas that they sampled in the beginning, in the 70s, they changed the land use. So we should have stable soil monitoring units across the time. I don't know how this is going now in the new versions of the soil monitoring law, but what we had the information before, that they still had the land use as one of the inputs for the delineation of the soil units. And what we have now, another point of the soil monitoring is the soil sample. So we have here Lucas soil, and it was already presented by Ariel that they had from 2009 to 2018, but I just want to show here the case from Denmark, how they improved the number of samples in the last survey. So in Denmark, they went from an average of 200 points in the previous surveys to 1,300 points. So it was a huge increase. But how these new points, if we combine them with the idea of soil units, how they are related. Are they representing all the soil units in the Danish landscapes? So these are questions that it's also one of the deliverables of AI for soil health, is to suggest a redesign of the Lucas. So we are also working this. Maybe there are some soil units that they are not samples in the soil units. So we are also working on it. And what to do with all those samples? As I say, we have also to try to support the farmers. And here is an example how we could support the farmers. I selected 2 regions here. The light green area in England and part of France, and the Mediterranean region. And here, this plot is showing here the soil organic carbon distribution from the Lucas samples for these 2 regions. So what we can see, the top one is for the northern region, and the down plot is for the Mediterranean. So we see that they have different conditions. So these are true samples, not simulated data. What we could do here, following the experience from UK, is to set targets and thresholds. But there are many issues related to it, because how can we say that the lowest part is bad or good? But I think it's a way to start doing this. For example, here we can see that the lowest threshold, maybe for the north part, would be bad. But if we look for the Mediterranean, are the normal values for the Mediterranean region. So now the member states, they may have the opportunity to set their own thresholds, right? So how will you harmonize this across Europe? We don't know yet. But there is also another opportunity when you talk about soil monitoring system in time. If I'm a farmer, I collect my soil sample and I measure for soil organic carbon, and I'm here on this point. For the future, I have 2 options, 3. In 10 years, I can be at the same point, so my soil organic carbon is the same, or my soil organic carbon is going to decrease or increase. And here is a point I'd like to highlight. We call it the relative change. It's difficult to say if my soil is health or unhealth. But if I look in time on my second monitoring period and I say, okay, I improve my soil condition, then I can say, okay, I improve my soil health. And then we talk about soil health development. But if the soil organic carbon from my farm went down, so I decrease the soil health. But all this relative change and setting thresholds and targets, we are still discussing this, and we will have to agree somewhere in the future. But we talk first, this is just about cropland, what I presented. This is just about cropland, but when we see, we can do it for other land use. For example, the grassland, we see a big contrast between the 2 regions. And also is also an opportunity to see, okay, what my peers in the good position of the distribution are doing. Are they regenerative farm? So it's also opportunity to work on it and get more information about management. And if I set strict thresholds here, I could translate it to the space. So the thresholds, they will help farmers, but at the space, they will help politicians and to say, okay, we have this area, we need to focus in these areas because here we have problems. This is what we did for Denmark. My colleague Sebastian just published the paper. We have here the maps, it's just a region in Denmark. Each map here represents one soil descriptor, and the red color is below typical values, and the green color is above typical. Oh, like the red is bad, the green is good. So these maps, they are 10-meter resolution. So politicians now can say, okay, in this case, in this region, we need to focus on soil organic carbon decrease and bulk density. Nitrogen leaching is not a problem here. Or water erosion is not a problem. So then we start to target actions from the policy perspective, but also we have the farmers. And here on the right side, we have the points. We have, in Denmark, we have a lot of data. So if I'm a farmer, if I have a grassland, a permanent grassland, or if I have a cropping rotation, or if I just have crops all the time. So I have here the distribution of what we know already. So the farmer can just place, okay, I have grassland. In which position I'm compare with my peers. So here, the idea that we can support, give information for policymakers, but also for farmers. Yeah, thank you.